Hey guys, welcome back to another video. We're going to do some more rational inequalities. This is the second video. Here we go. We have a third example here. This is a rational function, but it's already in the factored form. Okay, it's already in the factored form. We're still going to do our steps. Go back and look at your steps if you need to. And here we go. We're going to do this. The first thing we're going to do is we're going to set the numerator equal to 0 and the denominator equal to 0. So I'm going to do x minus 1 equals 0, 3 minus x equals 0, and I'm going to do x minus 2 technically not equal to 0 because it's the denominator. I don't have to worry about the squared one because it's the same one. So then this gives me x equal 1, this gives me 3 equal x, and this gives me x is not equal to 2. Okay, so those are my numbers, but now I've got to decide if they're open or closed. I got to put these on my number line and decide if they are open or closed. I'm going to have a big number line this time. And I can decide if they're open or closed. So I've got the number 1, I've got 2, and I've got 3. Okay, so now the numerator is equal to 0. It has an equal here, and so these are going to be closed because it is okay to equal 0. So I'm going to have closed on that one and closed on that one, but the denominator is always open. That one for the denominator is always an open circle. Okay, so there's my set. Now I have 4 sections to test this time. I have 4 sections to test. And we're testing for less than 0, so we're testing for negative or 0. That's what less than or equal to 0 means, negative or 0. Now we know what their zeros are because we already did that. So we're really just testing for negative. So what numbers am I going to plug in? I'm going to plug in 0. I'm going to plug in 0.5, which is between 1 and 2, and I'm going to have to plug in 2.5. No, wait a minute, 1.5, not 2.5, 1.5. There we go. So I'm going to plug in 0, and plug in 1.5 and 2.5. All right, so now this may be a little harder than what you're used to doing, but let's look at it just from a positive or negative. That's all we're looking at, positive or negative. I don't want to have to get into a bogged down with of numbers. I'm going to actually just decide, is this a positive or is this a negative? Otherwise, I'm going to get bogged down in the calculations. So I'm going to plug in 0, see what happens. So I have 0 minus 1, 3 minus 0, over 0 minus 2 to the second power. All right, well, that first one's going to give me a negative 1, and then it's multiplied by 3. That's negative. And then negative 2 to the second power is positive. So just looking at positives and negatives, I have a negative times a positive over a positive. And that's going to give me a negative answer. Now I know that it's negative 3 over 4, but in the next one it might be a little harder. So this one's negative. Am I looking for negatives? Absolutely. So this whole section is part of my answer. So what is this interval? This is negative infinity to 1, and it's a bracket on the 1. Okay. All right, next I'm going to plug in 1.5. Now this is where I'm not going to get bogged down in the decimals. I'm just going to do positive and negative. If I plug in 1.5, I'll change colors real quick. Let's do green. So I have 1.5 minus 1, 3 minus 1.5, and then 1.5 minus 2 to the second power. Now, again, I'm just going to decide if this is positive or negative. So when I do 1.5 minus 1, I get a positive number. When I do 3 minus 1.5, I get a positive number. When I do 1.5 minus 2, I get a negative number raised to the second power, which is going to be a positive number. So if I take a positive times a positive divided by a positive, I'm going to get a positive. And I'm looking for negative, so this is no. I'm not going to color that one. See how I did that? I didn't have to actually do the fractions and the decimals because all I'm looking for is it positive or negative? That's the beauty of having it say less than or 0. Okay, 2.5. Let's do it. Plug in 2.5. Switch colors to blue. All right, so I'm going to do 2.5 minus 1. That's going to be positive. Times 3 minus 2.5. Well, that's going to be positive. And 2.5 minus 2, well, that's positive. Squared is positive, so this one's positive. And so, no, this is not in my answers. All right, now we're going to check another number. We've got one more to do. One green, right? Do a green one. And we'll check 4. I don't have to do 3.5. So now I have 4 minus 1. That's positive. 3 minus 4. Well, that's negative. Over 4 minus 2 to the second, which is positive. So this is negative. That's going to give me a negative. So that is definitely part of my answer. And this is the closed interval from 3 to infinity. Okay, so here we go with my answer. My answer is negative infinity to 1. We have a large gap from 3 to positive infinity. This is the answer right here. All right, we've got another one to do. Here we go. Now this one we're going to have to factor. And so here we go. We're going to take the numerator, set it equal to 0. So we have x squared minus 3x minus 4 is equal to 0. This factors. 4 and 1 minus 4 plus 1. So I have x equal 4 and x equal negative 1. And then I'll do the denominator. X squared minus 9x plus 18 is technically not equal to 0. I'm going to factor it. It's going to be 6 and 3. Minus 6 and a minus 3. So that's x cannot be equal to 6 and x cannot be equal to 3. Remember, these are not equals because they come from the denominator. Your denominator can never equal 0. So now, once again, I have a very large number line. I'm going to put these on my number line. All of these are going to be open. There are no equals, technically, so they're all going to be open. So let's put them in order. So negative 1 comes first, and it's open. Then we have positive 3, and it's open. Then we have positive 4, and it's open. And we have positive 6, and it's open. Okay, we're going to check each section. We're going to test a number in each section. So I'm going to start with negative 2. Again, this is greater than 0. And so I'm looking for positives. Now I am going to give a little bit of a cheat, and I didn't do this just a minute ago. Let me squeeze this in here. Give me a smaller font. This function, this rational expression, in its factored form is x minus 4 times x plus 1 over x minus 6 times x minus 3. That's what I'm going to plug into. Now I can plug it into the original, but I'm going to plug it into that one because I'm going to use this to see if it's positive or negative. I'm not going to actually worry about the numbers themselves. I'm just going to see if it's positive or negative. So watch how I do this. Plug in -2. So that's a -2 minus 4. Well, that's a negative. Times a -2 plus 1. That's a negative. Over a -2 minus 6. That's also a negative. And then a -2 minus 3. That's also a negative. So a negative times a negative is a positive. Over a positive, this is positive. Notice I did not do the calculation. Feel free to do the calculation if you want to. It's not wrong, but that's not what I need. I just need to know the sign. If I actually plugged in the numbers, it might actually take longer. So positive, yes, this is what I'm looking for. So these are in fact part of my answers. This is definitely part of my answer because I'm looking positive. All right, let's pick another color. Let's do pink. Although I know I've been using pink for my answer. So I'm going to put a number between -1 and 3. I'm going to test, let's test 2. All right, so I'm going to do 2 minus 4. That's negative. 2 plus 1, that's positive. 2 minus 6, that's negative. And 2 minus 3, that's negative. This is going to give me a a negative on top and a positive on bottom. So this is going to be a negative. That is not in my answer section. Next, I'm going to keep doing this. You can stop the video until you get caught up with me. I'm going to do 3.5. Here's where it's really nice to know if it's positive or negative. So 3.5 minus 4, that's negative. 3.5 plus 1, that's positive. And 3.5 minus 6, that's negative. 3.5 minus 3, that's positive. Okay, so I'm going to have a negative over a negative, which is positive. Woohoo, I got an answer. That's what I'm looking for. Greater than 0 is positive. So this one, this is part of my answer. Let's keep going. Next, I'm going to plug in 5. So 5 minus 4, that's positive. 5 plus 1, that's positive. 5 minus 6, that's negative. And 5 minus 3, that's positive. This is going to be a positive over a negative. This is negative. Not my answers. Nope. Nope. This is a yes, and this is a yes. I need to switch colors. Last one, trying to hurry up. I'm going to plug in 7. If this pattern holds, this one's going to work, right? All right, so 7 minus 4, 7 plus 1, 7 minus 6, and 7 minus 3. It's a positive times a positive over a positive times a positive. This is positive. Yes. So again, there's part of my answer. All right. So now what is the official answer? Here we go. I have from negative infinity, this is negative infinity to -1. This section is 3 to 4, and this section is 6 to positive infinity. So those are my answers. Negative infinity to -1, union, 3 comma 4, union, 6 to positive infinity. All right. It's just math, y'all. This is some serious stuff, though. So it's a lot of work. Think it through. Don't get lost. Just remember, it's just math.